So, another category or perspective of classifying suspensions is from the perspective of the connection between the left and right wheels on the same axle, right. So, let us look at how we can essentially classify suspensions based on this criteria. Okay. So, based on this we have broadly two classes. Okay. So, what is called as a rigid axle or dependent suspension and an independent suspension. So, this rigid axle is nothing but is also called as a dependent suspension. So, what are these two classes of suspensions? So, as we can see in this schematic indicating the rigid axle or the dependent suspension, we can see that the left and the right wheels, okay, are connected by means of a rigid axle. So, as a result, if let us say this wheel hits a bump, this wheel is going to travel up. So, what is going to happen is that the entire vehicle body will roll and this is going to be pushed off. So, any perturbation which is felt by one wheel is transmitted to the other wheel in a rigid axle or dependent suspension. On the other hand, in an independent suspension, let us say we have the left and the right wheels, what happens is that when the let us say once again the right wheel hits a perturbation, right, then the right wheel may be displaced, but then we can see that the displacement is absorbed, right, by the suspension linkages, and consequently the maybe the disturbance which is transmitted to the other side is fairly low. Okay. So, that is an important feature of an independent suspension. So, let us look at both. Okay. So, first let us look at dependent suspensions, and we would then look at various realizations of these dependent suspension. So, a rigid link connects the left and right wheels, So, of course, the motion of the wheel assemblies and the tires are dependent on each other, the vertical motion, right. So, yeah. So, consequently there are a few limitations. Okay. We have issues related to handling, that is what happens when we steer the vehicle, right. So, and then issues related to ride comfort and road holding, because the unsprung mass is more. Okay. So, this is going to impact suspension performance including ride comfort. Okay. So, those are all limitations of a dependent suspension. Okay. So, on the other hand, an independent suspension has advantages. Okay. What are they? Those. So, the two wheels can move independently as far as vertical displacements are concerned, right. So, then but then like what we have is that like we have suspension elements such as control arms, okay, wishbones, trailing arms, okay. So, these are all elements. So, because see it provides some relative motion between the wheels on either side, but then like there should be some support also, right. So, at the same time as far as the structure is concerned, so these elements link the vehicle frame and the suspension, okay, and transfer loads between them, right. So, that is what happens in an independent suspension. So, what are the advantages? Advantages include lower unsprung mass, okay. We will shortly see that we can require a smaller space requirement, okay, which becomes important when we want to mount these suspensions on the drive axles, right, or the driven wheels, and disturbance on one wheel is not transmitted on either side's wheel is not transmitted to the other side to the greatest possible extent, right. So, that is the advantage of the independent suspension. So, let us look at common realizations of these suspensions, okay, in road vehicles, right. What are the different ways in which these independent and dependent suspensions are realized. Let us look at a few common types and then like we will study the features. So, the first type of independent suspension that we will look at is what is called as a McPherson strut suspension. Okay. So, this is what is called as a McPherson strut, and let me also have the control arm schematic. So, this is the McPherson strut and this is a schematic of what is called as a control arm. So, yeah. So, what is this McPherson strut suspension? It is a very popular suspension that is used in it is a very popular independent suspension, right. It is used in small cars, right. So, let us identify how it is constituted and what are its features. So, we have what is called as a strut, okay, an element called as a strut that houses the spring, and also inside the spring there is a shock absorber, okay. So, the shock absorber and the coil spring are wound in parallel, right. So, this arrangement, you know, like some people will say coil over oil, okay, in a colloquial sense, right, because we have a coil spring around this oil filled shock absorber, right. So, very compact, right, you just have the strut, you just mount it to the wheel assembly and the vehicle body goes here, right. This is connected at the top to the vehicle body, that is about it. Very nice, you know, like and it is very advantageous to have when we are driving the front wheels, because the suspension itself only takes up very little space. So, those are all pretty good advantages of the McPherson strut, simple in construction and realization. However, we can immediately see that we have to provide some other elements to support the wheel assembly in the other directions, that is the longitudinal and lateral directions, right, with respect to the vehicle body. That is where we have what are called suspension arms or control arms. So, this is a control arm which is typically connected at the bottom, okay, here. So, what happens is the control arm is connected to the steering knuckle through a ball joint, right, and this other end of the control arm is fixed to the vehicle frame or the vehicle body, okay. So, that there is some support between the wheel assembly and the vehicle body, right, along the lateral direction. So, that is the role of a control arm in this McPherson strut assembly, okay. So, the McPherson strut has typically a strut assembly and a lower control arm So, the strut assembly contains the spring and the shock absorber. Okay. So, of course, the top end of the strut is connected to the vehicle body. The main advantage of this is that like it is compact, so suitable for compact cars, right, where space is a premium, right. So, packaging everything becomes very important, right, and particularly where the front wheels are steered. So, where we have front wheel steered cars, this becomes important, okay. And since the strut is used as the upper suspension link. So, we can see that there is a control arm which is a lower suspension link, okay, because we have the steering knuckle, right, which supports this wheel assembly. So, the strut is connected close to the top, okay, and then the lower control arm is connected to the bottom, right. So, since the strut is used as the upper suspension link, so we have more clearance for the drive shafts, okay, because if you want to drive the wheels, right, I need a drive shaft, I need to put in a drive shaft, right, isn't it. So, we will have more clearance for accommodating the drive shaft in a front wheel drive vehicle, right. So, more clearance is available for the drive shafts in a front wheel drive vehicle, okay. So, that is one main advantage of a McPherson strut, simple, compact, easy to mount and accommodate, right. So, popular in compact cars, but what are limitations? Main thing is that when suppose if this wheel hits a bump, right, and when we corner this is going to rotate, right. So, what is going to happen is that the camber of the wheel is going to change, okay. So, the McPherson strut cannot take care of that aspect and consequently that is going to affect the handling properties. So, the wheel camber angle changes due to wheel movement. So, the McPherson strut is not very effective in addressing this. So, this implies that the McPherson strut suspension does not provide as good a handling performance as the next choice that we are going to look at, which is what is called as a double wishbone suspension, okay. So, that is one limitation of a McPherson strut suspension, okay. all right. Okay. So, now that leads us to what is called as the double wishbone or A-arm suspension. So, what is this double wishbone suspension? So, it is once again a very popular type of independent suspension. So, how is it realized and what are its characteristics? So, if you look at a double wishbone suspension, so we have two suspension arms or links that are shaped like a wishbone, right. We can immediately see that we can essentially see that these are in the shape of an A or a wishbone, right. So, that is why it is called as a double wishbone or an double A-arm suspension, okay. So, that is the reason. So, these two suspension links are shaped like wishbones or like an A. So, what happens is that we can immediately see that these two wishbones are connected to the steering knuckle at the upper ball joint and the lower ball joint, okay. So, there are two ball joints at which these these wishbones are connected. So, there is good support at both the bottom and the top, and then that other ends of the wishbone, two wishbones are connected to the vehicle body, okay, this side and this one, alright. So, there is good structural support between the wheel assembly and the vehicle body. More importantly, we will see that if we make the arm of the upper wishbone smaller than the lower wishbone, you will see that the moment the wheel hits a bump, these 2 points will traverse on arcs of different radii, okay. Let us say the upper wishbone is smaller, the arm length is smaller than the lower wishbone. So, this point will travel on an arc of smaller radius than the bottom arc, right, is not it? Then we will immediately see that it will naturally introduce a negative camber, which is good for handling performance, okay. So, we discussed this even during wheel alignment, right. So, why do we have negative camber? Because when we are cornering, we want good contact at the outer tire interface, right, but the inner tire also we do not want to lose contact, right. So, this double wishbone can adjust the camber, right, such that it tends to negative camber, and there is a good, and the wheel will straighten up or the tire will straighten up when we take a turn. So, that the contact between the tire and road interface is maintained at reasonable levels, at the expected levels, okay. So, let us quickly write down the key points of double wishbone suspensions. So, has two wishbones are what are called A arms as the lower and upper suspension links, okay. Then compared to the previous choice, the double wishbone has better ride and handling characteristics, right, due to the reasons that we discussed. So, each wishbone is connected to the wheel assembly and the vehicle frame at its two ends, alright. So, that is one thing, and then we have what is called a short long arm suspension, what is abbreviated as SLA double wishbone. So, as we discussed, this is a suspension where the length of the upper wishbone is smaller than the lower one. Okay. So, the upper arm is shorter in length than the lower arm. So, hence as the wheel hits a bump, a negative camber is gained since the upper arm swings on an arc of smaller radius. Of course, what is the trade off? See, if you have the upper arm swinging on a arc of different radius than the lower arm, you will see that the tire will scrub side to side. See, now the tire is also going to be rotated accordingly, right. So, the trade off is that side to side scrubbing of the tires will occur with this arrangement. Okay. So, that is a trade off, right, with a double wishbone suspension, right. So, one more type which is sometimes used as independent suspension also to reduce the space is what is called as a trailing arm suspension. So, what is this trailing arm suspension? In a trailing arm suspension, we can observe that. So, these trailing arms are also used to provide structural support in other types of suspensions, but let us look at what is called as a trailing arm suspension, right. So, in a trailing arm suspension, we can observe that there is a spring and a shock absorber and there is no wishbone, right. The wishbone essentially projected into the vehicle, right, along the lateral direction. The trailing arm comes along the longitudinal direction. Okay. So, that is why it is called as a trailing arm. So, if you recall, the wishbone essentially went into the vehicle, right, as from the lateral direction. The trailing arm goes along the longitudinal direction of the vehicle. Okay. So, that is why it is called as a trailing arm. So, it goes and connects to the vehicle body. Okay. So, that is what is called as a trailing arm suspension. So, what is the main advantage of this trailing arm suspension? You know, like it basically it's pretty compact and what to say, particularly if you want to use it for use in driven wheels, it is a reasonably good choice. Okay. But however, you know, like it needs what to say, today these trailing arms are by and large used for providing support to other types of suspensions. Okay. So, that is the common use of this trailing arm, okay, along the longitudinal direction. Okay. So, we will encounter these trailing arms when we look at other types of suspensions. Okay. I will stop here and then we will continue in the next class. Thank you.